Hello. This tutorial is going to focus on Prometheus and the official exporter for Snmp. A couple things before we get started. I'm going to assume that you're working with Prometheus in Linux and that you're comfortable with Linux and that you also have some generalized knowledge about Snmp and MIBs and OIDs and I guess a couple networking concepts, but if you don't worry about it. So before we get going here, we have a Ubuntu virtual machine and we have a Vagrant provisioned virtual QFX 10K, which is a Juniper switch. The Ubuntu VM has Prometheus and Snmp exporter as a service, and it should be running. And then the QFX has a basic Snmp config. Both machines have a host-only adapter attached so that they are getting a DHCP lease from VirtualBox. We can see one of the management interfaces has a 192.168.56.9. The Ubuntu VM is 56.11. So they're on their own private network within VirtualBox and can talk to one another. If we look, Prometheus is up and running on 56.11, port 9090. And it should just be scraping itself, yeah. So it's just getting some internal Prometheus metrics right now. Another thing that the Ubuntu VM has is a working Go environment, which is going to be necessary if you want to build the config generator tool that the Snmp exporter repo has. So I'm going to put a link in the description for getting that set up. It's pretty easy. There's just a couple commands to run. It's easy to test. So hopefully by the end of this, you can have a dev box up and be monitoring with Snmp, and you'll know how to change the configuration around and extract certain information and learn how to control the Snmp exporter. So if we jump in here, out of the box, you do get a configuration file with Snmp exporter. It's going to be named snmp.yaml. And it is kind of a large file that's made up of various what are considered modules, which are just these YAML keys at the top here, at the top of each walk. So we have AP, APC, UPS, and it's a large file. So it might have some modules in there you don't need, or maybe you just want to target certain OIDs, certain MIBs. Maybe you want to chain certain MIBs together. So one of the limitations here is that you cannot chain specific modules together. So if you wanted to scrape your interface MIB and a system MIB that has uptime and system name and description and contact, you couldn't chain them together. It'd all have to be contained in one module. So we'll do a couple use cases in this tutorial that show you how to change some of that stuff. And Snmp exporter isn't that different than some of the other exporters. This relabel config here follows the same standard that Blackbox exporter uses, if you're familiar with that. But this is very important, and you don't need to know what this does, but just know that this needs to be on a job where you're scraping Snmp. So Snmp exporter typically will run on the Prometheus instance itself, and you will want to scrape the local host on the port number that Snmp exporter is listening on, and this magic relabel config here will append it'll do a couple things, but it'll take this target IP address and basically pass it as a URL parameter. So before we get started, let's grab a couple Snmp utilities that are going to help us with some troubleshooting. So we're going to do an apt-get install snmp on this Linux VM, and it's going to go and grab some Snmp utilities for us. So now we can do an Snmp walk against this Juniper switch, and we're using version 2, tag C. Our community string is going to be public. I think that's what I set it as. And we need the target parameter, and I'm just going to do a .1 and cancel it real quick. Okay. So you can see we're getting some data back from that walk. So that's good. So we have good connectivity. So you can see that these are just mapping to OIDs, which isn't great for us. We would like that to be human readable for troubleshooting purposes in the future. So let's go ahead and grab Snmp MIBS downloader. This is going to go out and fetch some MIBS for us, and it'll put them in a place where Snmp libraries can use them and read from them. And it's not going to be every MIB under the sun, but it'll be a good start. And then later on, I can show you how to add vendor-specific MIBs. So while that's doing its thing, Snmp exporter needs to run on the Prometheus instance or another VM, because a lot of switches and routers are vendor locked to their operating systems. So you're not really allowed to install custom software on them unless you're working with some white box switches or something along those lines. So it looks like MIBS downloader is done, which is great. So let's run that again and see if it resolves to human readable names. Let's do another walk, and I see it doesn't. So I think we need to tell Snmp to reload those. So we're going to open up the Snmp configuration file. Loading of MIBS is disabled by default. If you added MIBS, you can re-enable loading them by commenting out the following line. So let's comment those out, save that, and let's rerun that again. And it looks like we're getting some human readable stuff, which is great. System contact, name, location, along with the MIB name. So here's interface MIB. We have our interface indexes here, which is great. So that looks good. So let's take a look here through our repo that we have open. I'll put a link in the description to this if you don't know where this is. So the Snmp exporter reads from Snmp YAML config file by default. This file is not intended to be written by hand, rather use the generator to generate it for you. So let's go take a look at that generator. So it's some Go. So it's going to use net-snmp to parse MIBS and generate configs. So I'm using a Debian-based distribution. So why don't I go and grab these prereqs, build essential, and an Snmp library, and it looks like it's grabbing unzip. So let's go grab that. One thing to note is Snmp MIBS downloader. If you are running this on Debian, I believe you have to add the non-free repo to your source list, and then do an apt-get update, and then you should be able to install Snmp MIBS downloader. Looks like we grabbed our prerequisites. Now we're going to run a go get, and that's going to grab this generator path for us, and then we're going to change directory into our go path, and that'll put us in the correct directory. Looks like it's still grabbing it. So that's done. So let's change path and let's see what we've got here. Okay, just a bunch of Go stuff, and let's do a Go build. And after the Go build is done, we should have a generator binary file. All right, let's double check. There we go. We have our generator file here. Cool. So let's see. Wants me to make MIBs. I'm not going to do that since we have Snmp MIBs downloader and we have a special directory for our MIBs. I'm not going to set that variable, but I can see that if we want to run it, we have to do /generator generate. So the generator reads in from generator.yaml and writes to snmp YAML. So every time we run it and it's successful, we need to remember to copy the snmp YAML it generates in this Go path here and copy that to the directory that the snmp exporter service is using, which is etc Prometheus, which is a directory I made. So looks like they list the file format, which is great. List of modules. Simplest module is just a name and a set of OIDs to walk. So module, you specify a name and then you specify an OID or a name. You can go as far as specifying an OID by interface index. So it's you get some really good granular control. And I think this is important for when you're working with older devices. You really don't want to overwhelm them with SNMP polls, and I think it's good to be really focused with what you're pulling. So if you have a device that has hundreds of port channels, you know, maybe you don't want to pull a full MIB. Maybe you just want traffic. Maybe you want octets in and out, packets in and out, and is the interface up, down, and maybe errors and discards or something like that. So you want to be precise with maybe 10 OIDs rather than scraping a whole tree. But this is going to allow you to be very granular, more so than the default configuration. So I'm connected to this Ubuntu VM in VS Code. So I'm going to open this directory because it's going to be easier to work with in VS Code rather than opening it in Vim or Nano. So let's open the generator directory. Let's take a look. We have a generator.yaml. So this file contains the generator configuration that the default snmp.yaml config is generated from. So it's got some good stuff in here. So this interface MIB one I am going to keep, but the rest of them I'm going to get rid of. Okay, so let's change our module name here to something obvious. So ifmib. This is where you would set your SNMP version. So we're using version 2 with a very simple community name because it's a test environment. Don't recommend that for production. You should use v3 where possible. So if you are using v3, you just change that to a 3 and fill in all of your auth priv information down here, and the generator will use that. So we can get rid of all this v3 information. And let's tighten this up. Max repetition's fine, timeout's fine because we're not doing too many, and I know it's going to complete in 10 seconds. So this is where we start to see some of the power of the generator. So what I want to do here is I want to go take a look at ifmib, and I like to use OID view so we can get an idea. So here's the MIB with object identifiers for the tables down to the single entries. So really I just want IFX table, which contains interface name, the speed, high speed reports your port speed in megabit per second. Let's see, interface. So the interface X table has 64-bit counters, so it's going to take longer for them to roll over, and that's what the HC means. So let's grab this OID here, and let's pop this in there, and let's get rid of these two. I don't really want the uptime in there with it. We'll get rid of that comment. Okay, one important part here that I want to highlight would be the lookup section. If we don't include this lookup section, what's going to happen is when we poll the switch, all of our metrics are going to come back with just the interface index label on them, and that's just a number. And when you're working with PromQL, trying to get meaningful information out just based on the interface index, it's going to be really hard to, from a human perspective, to figure out what interface that metric belongs to without having an interface index map in front of you for that specific device. So it's really not usable. So this lookup section is going to take the interface index and look up interface alias and interface description and append those labels to our metrics. So interface alias is going to be the user-defined description on the interface, and then interface description is going to be the name of the interface. For instance, 10 gig Ethernet 101, whatever. For Cisco, Juniper would be like ET-000, whatever. So very useful, very important to have this. You can change this around to different things. Might be worth experimenting depending on what your use case is, but now that we have this and the syntax looks good, let's go ahead and generate our new Snmp config. One error, not going to worry about that. 19 metrics were written, and it was written to Snmp YAML in our Go path. So generated 387 lines of config for 18 lines of generator config, so that's pretty cool. So why don't we go ahead and remember we need to copy that Snmp YAML out to the directory that Snmp exporter is going to be looking for. I'm going to do an ls tac lah on etc Prometheus, and let's make sure this is 103, which is UTC 803. Cool. East Coast. So now let's restart Snmp exporter so it picks up the new configuration, and let's go ahead and verify that it was syntactically correct. All right, it's listening. Cool. So if we reload this, we see nothing there. We didn't make a Prometheus job. So let's go grab this guy here that I already had highlighted, and let's make a job. So let's say this is job name VQFX-SNMP. Target is going to be 56.9. And if mib is not correct, remember we renamed it to if-mib, all uppercase, and we're going to leave in our very cool relabel config stuff. So let's give that a save. And I don't have the admin API endpoint on, so I can't reload Prometheus with a curl. I need to do a signal interrupt on Prometheus. So let's kill 16900. And okay, yep. So we reloaded and it was good. So if we refresh our Prometheus here, we should see we have another target. Right now it's currently unknown because it hasn't performed a scrape yet, and I think I set it 15 seconds is very generous for Snmp. I probably wouldn't do that normally, but I guess for testing it's okay. So after 15 seconds we should see it come up. Okay, so last scrape 11 seconds ago, it completed in 312 milliseconds. So let's see if we're getting some. So interface. So this is cool. We can see we have some metrics for interface outbound octets. Some of them have interface description, interface index as part of the name, and then we have our job, and our instance is the target URL. And if interface alias isn't blank, it populates with the user defined description. This is really important and can't be understated when you're working in Grafana especially. It's very helpful to have these things on here and follow a standard, because then you can do stuff like rate of interface where the interface alias is equal to a regular expression. That's management star, and we'll take a 30-second average, if I could put that in the square brackets, maybe one day. Hello, there we go. And let's close that off. So this is just going to show us outbound octets for any interface that has management in the beginning of the description. So stuff like that is really powerful when you're building dashboards in Grafana. And if we multiply that by 8, we will get our bit per second rate. And if we graph that, we see not much data. But if we zoom in on that, we can start to see it's holding steady. So very cool. And then we have interface speed. Get rid of that. So again, this is in megabit per second if your interface high speed. All right, so now that we know we're scraping and we've got some metrics coming in for things we want, let's take a look at getting some vendor-specific MIBs in here and tailoring our Snmp module to do some vendor-specific stuff. So I've gone ahead and downloaded some Juniper MIBs, and we are going to put them on the target machine. So let me I think it's in downloads, and I think it's called Juniper MIBs. I think I extracted them. Yeah, okay. So we want to take, this is actually going to be a recursive SCP because it's a directory, and we're going to say root at 192.168.56. This is 11, and I know that Snmp MIBs downloader puts MIBs in user share Snmp MIBs. Boom. Okay, so let's double check that. Let's list all in here. Okay, so we have Juniper MIBs as a directory. So I don't know if it'll look in the directory. I haven't tested that. Normally I put them top level in here, but we can go ahead and give that a shot. So let's find Juniper MIBs. Let's say Explorer, if I could type Snmp Mib Explorer. That was easy. So let's navigate through this tree. Craft alarms. So we've got a yellow alarm and a red alarm. So major and minor probably. So this is a pretty small one. So I'm going to say we're probably safe to just grab the whole thing. So we've got that OID copied. Now we can't chain modules. So we can't chain modules in that Prometheus configuration. So we can't do an IFMIB and then a JunoS alarm MIB, anything like that. So we have to think, do we want to make a new module named alarm MIB, or do we want to add the OID to the walk and change the module name? I think we're probably going to be safe to just, since this is a virtual machine and we saw that the polling returned in 300 milliseconds, I'm going to say we can just add it on here, and let's format that properly. And this comment isn't relevant for this one because it went down a line. Let's cut that in, and let's call this something more specific, like JunoS interface alarm MIB. How's that? And why don't we give that a save, and let's regenerate and see if the generator actually finds that JNX alarm MIB, which we should have. We'll see. It might error out. Yeah. See, so it's saying it can't find that OID to walk. So that's not good. So I want to take everything that's in this Juniper MIB directory and I want to pull it out and put it in this top level here with the others. So let's do copy recursive user share Snmp MIBs Juniper MIBs star to user share. You could do a move instead of making a direct copy of all these, which is probably the smarter thing to do, but that's okay. So now I'm going to do user ls share. Let's double check. Okay, yeah, so now they're really cluttering up the, but we see here's a MIB JNX alarm.txt, so hopefully that OID's in there and it knows to look. So let's rerun that generator. So we had some parsing errors, but it did generate 26 metrics, so if MIB had 19, so that makes sense. And a new config was written to Snmp YAML. If we go and check that out, okay, here's our Juniper alarm MIB. And let's see, did it put it on the end? Yeah, it looks like it puts it on the end, and there's some enum values here, so that's nice. So we got our yellow alarm states, relay mode, yellow alarm count. Okay, cool. So remember, we've got a new module name now because it's not just interface MIB. So we're going to kind of tailor this to be a Juniper specific. So let's go ahead and update our Prometheus job, and this is no longer going to be that module, it's going to be that one. So let's do another Prometheus reload and double check. Okay, it loaded. Now let's copy Snmp exporter to etc Prometheus, and then let's do a restart of Snmp exporter, and we'll double check that to make sure it didn't error out. All right, so that's running. So okay, it looks like it got scraped 3 seconds ago, and let's double check here. So we've got JNX red alarm count 0. That's good. I guess it's a virtual machine, who cares? Alarm state is 2. So I can't remember what 2 means. Let's go back to our enumerator. and see if 2 has red alarm state. 2 is off. So the red alarm indicator is off. So this would tell you if the LED is lit on the front of the device or not. And it's off. Cool. So we were able to add a vendor-specific OID pretty easily. So I think the only other thing I wanted to show you is that, for instance, if you wanted to add a new module, you would just break it out like so. For instance, if we wanted to do a system MIB scrape for vendor-specific, you could break that out into individual modules, or add it to your previous. And a lot of this configuration is going to depend on devices that you're polling, the types of devices, how powerful they are, how much configuration they have, what their workload is. It's all highly dependent on what you're doing. So there's going to be a lot of testing involved as far as how often do the polling sessions complete, and there's some trial and error in there. So most Snmp monitoring systems default to 5-minute polling sessions. So if you have modern day routers and switches, they can usually handle sub 2-minute polling without much issue if they don't have many interfaces. So you should be able to do sub 2-minute polling with a lot of modern equipment. Older equipment, 5 minutes might be good enough. So you can default to that, and you can, of course, you can always set the scrape interval independent of the global setting here. So this is just the default that every job will get if you don't specify a scrape interval inside the job. So you can set the scrape interval and scrape timeout. You can also manipulate your retries and timeouts from the generator file here, and that will be reflected in your new Snmp YAML file. So that's one way to control some of that stuff. I would read more about it before doing anything drastic, but 2 minutes to 5 minutes is usually the sweet spot. Again, there are other exporters out there for some of the big vendors that people have written. So maybe later on I can cover some of those that use netconf, or they SSH into boxes and they scrape, and they're a little bit more efficient than Snmp, but for a lot of older devices, you're just locked into Snmp, and there's really not much you can do about it. But Snmp Exporter offers a very flexible way to poll these devices and get really good data out of it. So I could do a little Grafana tutorial of how to get Grafana up and going, and a way to make some cool repeatable dashboards that are minimal effort. So I think I'll probably do that and split it out into another video. But thanks for watching. I appreciate it. And leave a comment if you have any questions or run into any problems. I can try and answer them. And have a good one. Thanks.